phones can expose it can expose wireless signals, right? Disperse wireless signals for computers to connect to. True or true? So your phones, please, this one now you have to unmute and you are speaking because it's going to be an assignment. You have to do it practically and then you show me what you did. So you are going to do a video of how you were able to connect two computers together and you were able to share resources, right? So what you will do is that you use your phone, which has the ability, which has the capability of dispersing wireless signals so that network devices or computers can connect to it. And when they connect to it, I want to see something, something you transfer. You can do a network test of using the ping command, for instance, or you might want to share you can share images, you can share files and all of that. So that's an assignment for you guys to try. Boris, when I say your phone can disperse wireless signals for computers or other network devices to connect to, what do I mean? What do I mean? What is that hardware on your phone that permits that thing to work like that? Boris?
Sir, please come again.
I said, remember, you have an MTN SIM, right?
Yes, sir.
You have an MTN SIM, and you cannot connect to the internet if you don't connect to what? To an access point name. APN. You've heard of APNs?
What?
APNs. So you are not connected to the internet if you don't connect to the APN. So APN is short for what? Access point names. Access point, just as you hear the word access point, you get the point. There is something on your phone that permits that devices can connect to, so that they can be on the same network and they can share resources, they can communicate. What is that?
Okay, sir. I might give like one or many because
all that you know.
Yeah.
The
Bluetooth.
Any that you know or all that you know. Perfect. One is Bluetooth. Beautiful. Any other one? Bluetooth is one. Yes. So you compare it, and then you have that small network created, and you know the pros and cons of Bluetooth, right? You know the pros. The disadvantages are many, as in the bandwidth or the channels. The wireless signal channels are not. So Bluetooth is one. Beautiful. Yes. For communication to go there, what happens? The devices has to be as close as they can to ensure that signals are transmitted at higher speed and all of that. So the Bluetooth is one. We mostly don't use it again, except the files are not heavy. If the files are heavy, then poses problem. So Bluetooth is one. Emmanuel, give me one too. Hey, Manuela, give me one. Manuela does not want to speak. So you have your hotspot. Your hotspot. How dare you forget about your hotspot? Your hotspot is a symbol that looks like this. Most phones will have it like this, right? You have something like this, and then you have some signals like this, right? So your hotspot, basically short for what? An access point. Devices can connect to it and what? Communicate as they are in the same network, right? They're in the same network. So there are a lot of things that happens when devices are on the same network. We are going to look at network devices and all of that. But now take note, these are the kind of resources that can be shared. You can share files and folders. You can also share printers, right? Printers, you can share printers, yeah, very possible. So you can send a print request to what? To a printer through a network. It's possible. I've done that. You have what? You also have these drives. You can share storage. An example is what? Google Drive, right? Even though it's it's something you have on the public internet, it's still a network. You know, the internet is still what? It's still a network. It's just that it's a bigger form of network. We call it a WAN, WAN. So you see, the same thing. You can share applications, right? You can share applications. You can share applications in a network. You can also share what? Internet connection. Beautiful. You can share internet connection. So those are the resources, right? So when you talk about a collection of computers that are connected together so that they can communicate and share resources, so you should be able to know the kind of resources and all that. Same thing, you should be able to know what these devices here stand for, which I think should be the next slide of our module or session for today. Good. Okay, we are first of all going to look at the types of networks. Very important. A LAN, please take note of this. You have a question today. So I've already given you one thing. You need to do a visual record of how you connected two computers, or your phone and a computer. All is that at the end, I want to see a possibility of what? File transmission or resource sharing. Please, as I'm saying this, be joking. So we have types of computer networks, and please, never you say you don't know these things. You need to be able to know the types and where they apply and what each means, right? So if I present to you a network, you should be able to tell me if it's a LAN, a MAN, a WAN, or a PAN. Please. It should not be the case where I present to you a network, you're like, oh, this is not a MAN, this is a WAN, this is not the local area network, all of that. So now let's look at it closely. What is a LAN? We start with a LAN, right? LAN is short for what? Local area network. Local area network. And so what is it? It is what? The type of network that is used within a building or what? Or a home, right? Small spaces. Yes, small spaces. Small buildings and homes and all of that. That's a LAN. You see, it can be used what? Within a building. So the building must not actually be small, basically. It must not actually be small. But the cost of implementing a LAN in a building is what is really low, right? It's low. But if the building actually is so big, that's when the cost can increase, right? Because think of a building like the one that has story building has very floors, right? You have floors, floor 1, floor 2, so you have to make sure that the connection, those that are the last floor can communicate with those at the second floor, those that are the second floor. So you see, to be able to maintain that network, to go that way between different floors and all of that, the cost increases. So the smaller the building, the lesser the cost, right? The smaller the building, the lesser the cost. And the bigger the building and the more levels they are, the higher the cost, right? Because you want to ensure that various computers in different rooms are connected together. Yeah. So you can do it through cable or what? Through Wi-Fi, right? Yeah. We always use WLAN, or we use what? We use a LAN. So we also have WLAN. WLAN is simply what? Wireless local area network. So you have the WLAN. So there is no big difference between the two. The only difference is that what? One uses wireless signals for transmission, for data transmission and receiver, while the other uses what? Wired channels, like Ethernet cables, twisted pair, like optic fibers, like optic fiber cables. So that's just the difference between the two. So it is used within a building or home, right? So spans a few hundred meters, not more than what? Not more than a mile, right? So you want to look at, you cannot go more than a mile. If you want to go more than a mile, it's going to be costly. Just imagine that, we wanted to establish a LAN between, that's Ekondo Titi, where's your school? Ekondo Titi and Kaskumba. We want to establish a LAN between Ekondo Titi and Kaskumba. Of course, that's really so. Bowie should be able to tell me that the geographical coverage, the geographical gap between Kaskumba and Ekonotiti, GBHS Ekonotiti is what? It's too large for what? To have a land being implemented here, right? Cannot implement a land with such a big geographical gap. You get the point? So it has to be confined within a building or a small home for it to be called a land. So please to take note of these things already. That's a land, right? Used within small buildings and all of that. So you have various speeds based on the kind of Ethernet cable you're using, or maybe the kind of cable that you're even using. Is it optic fibers or twisted pair? Yeah. So you see, mostly used in offices or what, or a school network, right? You see that. So in an entire school, you can what? You can build a school LAN. You can even build your home LAN, right? Yes. So that's a LAN. Hope there is no question on LAN. That's what a LAN is. Any question on LAN? Any question on LAN before we move to a MAN? Any question on LAN?
No, sir.
What's up with Emmanuel? Emmanuel, are you there? Okay, all right. So we move to a MAN, right? A MAN simply spans what? A city, right? Or a large campus. You get that? So it goes beyond what? Just a small building. You get the point? Yes. So when you have a kind of network that spans a large city, so you can have even a country, right? You can span the entire Boya, you can span even between cities, right? Yes, as long as it gives the possibility of what having the same communication possibilities and what resource sharing possibilities. That is a MAN. The take note of something here. Take note that computer networks here, these types specifies or is strictly based on what geographical coverage, right? So the first one talks about what just being in a building or in a home. Now with the Metropolitan Area Network, you're simply talking about what spanning an entire city. Let's say Boya, for instance, Boya, or you can say what a large campus, right? Who has been to large campuses? I've been to EUC in Boya. EUC is a large campus, for instance, right? Because if you go to a large campus, you're going to have multiple buildings. You get the point. So when the building becomes that large, you have to talk about a MAN. So it spans a city or large campus. Large campus. Campus has to be really large. Yeah. So you have distance coverage. You always have that specification. Optimized for what? For larger geographic areas. Just like we said, right? It can span more areas as more than lands. So an example is what is a cable TV network. So that's an example. You all have TVs, right? You all have TVs. You go to this house, you're going to see. I'm watching. I can watch CRTV. I can watch Equinox. I can watch this. You go to another person's house, maybe far from the same city. You can still have the possibility of watching the same channels and all of that. That's a network. Right, a MAN, Metropolitan Area Network. Then we'll move to a wide area network. In a wide area network, what are we doing here? It simply covers a country, a continent, or the globe. Right? And please be something here. There's something you should note. A one, a W, A N, right, is a collection, right? How do I put it? Many lands, right? Many lands. Many lands, a collection of many lands that work together, right, is what we call a WAN. A WAN. So if for instance Camtel wants to communicate with what MTN users, how does Camtel users, I think you have that possibility. You can subscribe to what? You can subscribe to bundles that works for all networks. You've done that, right? People have done that. You can use MTN to call Camtel, you can use MTN to call Orange and all of that. So that interconnection of what? Different networks, other forms of call what? A WAN, right? So you are basically connecting LANs together. Connecting LANs together is connecting what? Different networks together, different networks. And that's why a good example, which is not just limited to the internet, a WAN is not just limited to the internet, but the best example for a WAN is the internet, right? The internet is a good example of what? Of a WAN, right? Because the internet is the global connection of what? Computers, the global connection. Connect to the internet, you can communicate with anybody from anywhere, right? That's a WAN. A good example of a WAN is what? Is the internet. And I want to give this ask this question: who knows how the internet, who has googled on how the internet is, the architecture, internet architecture? How is it that I can send a request and I receive it maybe on time? Or let's just forget about speed, right? When you request for a web page, for instance, by typing a domain name, you receive the page in less than no time, right? Yes, forgetting even that speed. Now, how is it even possible? Have you thought about that? If somebody like Boris has not thought about that, then I should be very, very disappointed. Boris, how does the internet work? Question. What do you think is a specification of how the internet works? Boris. 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 Emanuela. Emanuela.
Yes, yes, sir.
What do you think is the specification of how the internet works?
See, actually, I don't know.
Okay.
Is not mentioned.
Okay. All right. So at least you have something to go and work on, right? Please, something I should tell you guys is that, see, if there is something that should be a part of you, is what? The spirit of curiosity. Curiosity. Is it witchcraft that we are having this class now? Is it witchcraft? Emanuela, is it witchcraft?
No, sir.
Is it witchcraft? Of course not. If it's not witchcraft, then why has Emanuela not said, oh, I want to understand the connection that has been made for this to be possible? Emanuela has not just thought about that yet. So surely now she has it in mind. She will go and find out. Right?
Yes, sir.
Yes. Good. I don't know what's going on with Boris. Boris is trying to avoid me. Yes, Boris is trying to avoid me. That's crazy. I will find his game. So good. So that's a wide area net. So a wide area network. So it's simply connecting what different lands. You have a connection of what different lands. So different networks, right? Different network segments that are connected together. You can call it a what? A WAN. And fundamentally, we say a WAN covers what? A country, and cover a continent or the entire globe. Or the entire globe. Right? Good. So that's beautiful. That's really beautiful. So how do we make this possible? We make use of what? Of some network device. We call them gateways. You can make use of routers, and we also make use of bridges. Right? Yes. So those are kind of network devices you can use to form a wide area network. Yes. So, but take note that we are saying that these types that we are specifying here are strictly based on what? Geographical coverage, right? Geographical coverage. So that's what these types of networks are strictly based on. You get the point. So with a LAN, you have small offices, right? Confined to a building. For a MAN, you have what? It can span an entire city or a large campus. Then you have a WAN. A WAN can cover what? An entire country. You have continents, right? Different continents, and the globe, the entire world, right? Yeah. So that is it. So we should be able to match the geographical coverage space measure to the various types that you know, like land. What is it? What is geographical coverage? What's MAN? Geographical coverage. What's WAN? Geographical coverage. Very important. Then we have PAN, which is what we mostly use, right? Bluetooth is an example. Personal area network. We see that this one is more close range, right? Bluetooth is an example. Around a few meters within a room. So we talked about LAN, right? We talked about LAN here. With a LAN, mostly when we talk about a LAN, you stress about a geographical coverage that is tied to a building. But with a PAN, you are actually looking at the span of distance that can be between the two communicating devices. Here you are talking about a few meters within a room. You get the point. So this is no longer tied to a building or an entire home. You have confined within a room. So you have meters, very few meters, right? If you use Bluetooth, like I've used Bluetooth, you see how you need to bring the devices so close before the transmission can go smoothly and all of that. That's Bluetooth, right? Yes. So laptops still have Bluetooth technologies, phones. They are in fact glad to see they are still very important though, right? They are used in various applications. One is proximity detection. We still use them for file sharing. You can even use them for to share internet connection. You can still use that. So Bluetooth, though facing serious network issues, speeds and all of that, we still need it in some way. Yeah, we still need that cases where it is best suited, right? So it's systems that make use of proximity modules and all of that. Bluetooth comes in handy. So I hope there's no question here. No question here, right? No question here, right? So we'll move to the next. We want to look at computer networks and components, and here we are talking about what's a network operating system. Simple, right? What's a network operating system? Just as you hear the word network operating system, it knows. What's a network operating system? It's simply an OS with built-in networking features. That's it, right? An operating system with built-in networking features is a network operating system. So with the built-in features, we are talking about network protocols. We are talking about network drivers, right? We are talking about directories. You get the point. And also we are talking about security. So all this to allow resource sharing across a network. So these are examples of various nodes. Network operating system. You have the Windows NT. You have the Windows Server 2000 and 3000. We have the Nouvelle Network, right? So these are various nodes. You have the Artisoft LAN static. So these are the various network operating systems that you can find out there. And if you want to build an infrastructure where you can manage different network users and all of that. You want to think of any of these, right? But the ones down here, they are multi-purpose, right? You know, Windows, Mac OS, they are multi-purpose. See, they are operating systems that they were made to bring in productivity with what